Alright, this is the lesson video for our Algebra 1 Summer School, Unit 1, Lesson 1, Combining Like Terms in the Distributive Property. Before we can move into the meat of the lesson today, we need to talk about a few definitions first. These words will be used throughout all of our Algebra 1 course. Let's fill in the following definitions on our notes. First of all, what is a term? Well, a term is a single number or variable. All right, a single number or variable. So for example, we have 2x minus 4y plus 7z plus 3. This is an expression made up of many terms. Notice that each term is separated by a plus or minus sign. So the 2x is a term, the negative 4y is a term, 7z is a term, and 3 is a term. How many terms are in this example? Well, the number of terms separated by plus and minus signs, there's 1, 2, 3, 4 of them. Our next question, our next definition is, what is a variable? Well, a variable is a letter which represents an unknown value. So again, a variable is a letter which represents an unknown value. In the example 7x plus 2, what is the variable? Well, we said the variable is a letter which represents an unknown value, and the only letter in this expression is x. So x is our variable. Next, we ask, what is a constant? Well, a constant is a value that does not change. A value that does not change. I like to say that this is the lonely number in an expression, the only value without a variable. So this is the lonely number in an expression. So again, the constant is the term in the expression which does not have a variable. Well, here in this example, x plus 2, positive 2, is the constant. It does not have a variable attached to it. All right, the last definition we need for right now is coefficient. A coefficient is a number that multiplies a variable. Most of the time when we have a coefficient is the number that is right in front and connected to the variable. So in this example, 3x, 3 is the coefficient. It's multiplying x. All right, so 3x literally means 3 times the value of x. In the example x, the coefficient is 1. All right, there's a little invisible 1 there. That's what I like to say, that the 1 is invisible. Now let's do a little practice just with identifying terms, variables, constants. Okay, so the first example we have is 3x minus 1. We need to identify the number of terms. Well, it looks here like I have 2 terms separated by that minus sign. So there are 2 terms in this expression. Next, the constant, again, that's the lonely number that's all by itself. The lonely number here is negative 1. The variable or the letter in the expression here is just x. And the coefficient that is on the x term is 3. That's the number right in front of the x. In the second example here, which is number 3, we have the expression 9x plus 7y plus 2w minus z plus 3. First, the number of terms. Let's see, I'm going to separate all these plus and minus signs here and count up how many terms there are. There's 1, 2, 3, 4, 5 terms. Now let's see if we can identify the constant. The constant is the number by itself, which here is 3. The variables are the letters, and there happens to be more than one this time. There's an X, there's a Y, a W, and a Z. This time, the coefficient we're looking for is the coefficient on the Z term. Well, that number that's right in front of Z is -1. Now that we can identify terms, constants, variables, we are going to put those to use. We're going to look at 2 properties today, the distributive property and combining like terms. The distributive property deals with multiplication. So we need to know how to multiply things together. Now, I like to say that when we're going to use the distributive property here, we need to draw a rainbow. Now, we're not actually going to draw a rainbow, but what the rainbow is it helps us remember what needs to get multiplied together. So in this first example, 2 times 3 plus 10, I'm going to take the 2 and draw a rainbow to the 3. That reminds me that I need to multiply 2 and 3 together. I'm also going to draw a rainbow from 2 to 10 because I need to multiply the 2 and the 10 together. All right, so let's start. 2 times 3 gives me 6. 2 times positive 10 gives me plus 20. Now, once I have multiplied and distributed the 2 to the 3 and the 10, I can now add those values together. 6 plus 20 equals 26. In the next problem, I take the 4 times the x to start. Well, 4 times x is simply 4x. Then I work on the next term. 4 times -2 is -8. Now, that's actually as simple as I can make 4x minus 8. We will talk about why in just a minute here, but we cannot simplify 4x minus 8 anymore. All right, the next example. I have y plus 1 times 4. Now, I'm still going to distribute this 4 that's on the outside. It just happens to be on the right this time instead of the left. So I start with 4 times y, which is 4y, and then 4 times 1, which is 4, so plus 4. Again, just like the second example, I cannot simplify that anymore. Again, we'll talk about why in just a minute here. There are a few more examples for you to do now. Simplify each expression using the distributive property. Go ahead and hit pause on the video. Try these 5 examples by yourself. If you need help, go ahead and hit play, and you can see me working out each example. So go ahead and hit pause now. All right, if you needed help with these examples, here's an explanation of how to do A through E of example 1. Here I'm distributing the 6 to both terms in this set of x plus 4. So I take 6 times x, which is 6x, and 6 times 4, which is plus 24. That's your answer for A. In B, I need to distribute the -3 to both terms. So I take -3 times 3, which is -9, and -3 times -x. Now we have to remember that a negative times a negative is a positive. So -3 times -1x is positive 3x. In example 1, letter C, I distribute the 4 to both the x, which is 4x, and the 5. 4 times 5 is plus 20. Now in example D, this one's a little bit tricky because we have to recognize that this negative that is out in front is actually a -1. So what I really have here is -1 times x plus 11. Once I realize that I have a -1 there, I just distribute the -1 to the x and get -1x, and -1 times positive 11, a negative times a positive is a negative. So I have -1x minus 11. Now I don't have to write the -1 here in front of the x. So an equivalent correct answer would be just negative x minus 11. Finally, in E, I distribute the 3 to the 5 first, which is 15, and 3 times 2x. I multiply the coefficients 3 and 2, which gives me plus 6x. Now that we've spent some time using the distributive property, let's talk a little bit about why we could not simplify these two examples up above anymore. That has to do with something called like terms. So we're going to deal with combining like terms. When I look at this table on the slide here on the right, I have examples of like terms and examples of not like terms. Now when I look at the column that says like terms right here, I have 3x and 5x, 2x squared and negative 5x squared, then 2x squared y and negative 3x squared y. So it looks like those terms in the column for like terms have the same variables and exponents. So like terms are terms with the same variables and exponents. Now when I look at the other side of the column for not like terms, well, 3x and 5y. X and y are different letter variables, so those are not like terms. 2x squared and 2x breaks the rules of having the same exponent. One has a squared and one does not. Same down here with 2x squared y and 2x squared y cubed. The y's have different exponents, so those are not like terms. Down below it says the expression 2x plus 7x plus 3 minus 2 can be simplified by combining like terms. We combine like terms by adding or subtracting the coefficients of each like term. So when I look at this example, it appears that I have 2x and 7x. Those are both plain old x's there. They are like terms because they have the same variable. So I add the 2 and the 7, which gives me 9x. Then I look at the constants. The constants here are plus 3 minus 2. Those are like terms because they both do not have any variable. So positive 3 minus 2 is plus 1. 9x plus 1 is the simplified form of 2x plus 7x plus 3 minus 2. Now on the other hand, I have this expression, 3x plus 5y minus 2z plus 11. That cannot be simplified because none of the variables are the same. Now if I look at this example, I have an x, a y, and a z. But because those are all different letters, I cannot combine them together. So that's actually the simplest that example can be. All right, we're going to finish up this lesson with 6 examples of combining like terms. Okay, so I'll do a couple with you. I'll do these first 2. Then I'll have you try a couple on your own. So example 1, I have 3x plus 2x squared plus 5x minus x squared. So I like to keep organized. I'm going to start with the first term here, 3x. It appears that I also have a 5x, which would be the same common like term. So because they're both x's, I can add their coefficients. 3x plus 5x gives me 8x. Then I look at the next term. I have 2x squared minus, remember this is a minus 1x squared. Well, 2x squared minus 1x squared is 1. 2 minus 1 is positive 1x squared. Or I can write that as just plain x squared. And number 2, both of these terms have an x squared. 3x squared plus 5x squared. Because they're both x squares, I can go ahead and add them together and get 8x squared. All right, go ahead and try 3 and 4 on your own. Hit pause on the video record or on your lesson video, and if you need help, go ahead and hit play, and you'll hear me explaining the answer. Now, number 3, the way this works is I'm going to start with the y's. I have 3y minus 2y. Those are like terms because they have the same variable. 3 minus 2 is 1, so I have that term as 1y when it's simplified. Now, if I look at the 2x, positive 2x plus 5x, those are both like terms because they have an x. When I add the 2 and the 5, I get plus 7x. So the simplified form is 1y plus 7x. Number 4 has a lot of terms spread out, but when I simplify it, it'll look much nicer. Let's start with the 5 here. 5 and 6 look like they're like terms. Those add up to be 11. Then I go to the next term that I have. I have an x here, and I'm going to try to find all the other terms with just an x. It looks like it's just 2 there. So I have a 1x plus 2x is 3x. Finally, the last one I have here is 4x squared plus 1x squared. 4 plus 1 is 5x squared. So that long string of terms simplified down to 11 plus 3x plus 5x squared. All right, last 2 examples here. This time we are combining the distributive property and combining like terms and putting them into the same problem. I always need to start by distributing first. So what I'm going to distribute here is the 2 to the x and the 2 to the 10. So remember, distributing is multiplying. 2 times x is 2x, and 2 times 10 is plus 20. Now I still have a plus 3 tagging on the end. I rewrite that all out, and now I look to see if I can combine any like terms. It appears the only like terms are 20 and 3. So when I combine those together, I get 2x plus 23. All right, last one here. I actually have to distribute 2 times in this problem. I'm going to start by distributing the 5 to the x and the negative 1. 5 times x is 5x, and 5 times negative 1 is minus 5. But then I have to distribute the negative 2. Well, negative 2 times x is minus 2x, and negative 2 times 3 is minus 6. Now that I've distributed and completely got rid of all the parentheses, I'm going to go ahead and collect like terms. So I start here with the 5x and the minus 2x. 5 minus 2x is 3x. And then I have negative 5 minus 11. Now be careful with the negatives. Negative 5 minus 6, negative 5 minus 6 is negative 11. That's your simplified form. All right, that completes the notes for Unit 1, Lesson 1, Distributive Property and Like Terms. If you go back to Canvas, there will be a practice lesson for you. There'll be a short video to go along with that if you have any questions.